So here you're asked to determine if these tables are exponential functions, and if they are, to find the formula. So the test for telling something is exponential, you would look at the change in inputs, which is you're adding 1 to all of these, so your change is 1, which means that you have evenly spaced inputs. It can be by any number. If it's 1, fine. And then you look at the ratio of consecutive outputs. So to go from 81 to 27, you are dividing by 3, but you want to look at this as multiplication. So you're multiplying by a third. 27 to 9, again, you divide by 3, but you can think about that as multiplying by a third and multiplying by a third. And so these are equal. You got the same number each time. So you have evenly spaced inputs. These are equal, so it is exponential. And we know a little bit more because we know the vertical intercept is 81. So A is 81. And the last thing we need to do is figure out the growth factor. So we know that our function looks like this. So you can use any other point besides the intercept here. So if I use just the first one, or the second one, 127, then I have 27 equals 81 times b to the first power. So b is just 27 over 81, which is 1/3. So your function is 81 times 1/3 to the power of t. Now, I will warn you that this number being a third and this multiplication factor being a third only occurs if your inputs are spaced by 1. So if you have an evenly spaced input that's something by 2 or 3 or whatever, this will not be equal to this number. So don't jump to this conclusion in general, because it won't work. Okay, for the second one, this table is correct, but I just noticed a typo in the solutions. So in this number used to be a 4, but now it's a 5, which was fixing the error, but then the solution file was not updated yet. So your solution will differ from this one, but what I'm about to do is correct. So first, your inputs are evenly spaced by 3. -1 to 2, 2 to 5, 5 to 8, adding plus 3. So we have evenly spaced inputs. Checks that condition. Here you're multiplying by 5. These are the same number, so it's exponential. Cool. So what we don't know is A, because in the first one, the intercept was given to you. Here it's not, and you can't really figure it out from here. So what you need to do is plug in 2 points. Doesn't matter which ones. So say 2.5 equals a times b squared, and 0.5 equals a times b to the negative first power. Just 2 points from the table go into the function. You then divide these. Because that cancels out a, you can then solve for b. So 2.5 over 0.5 equals a times b squared over a times b to the negative first power. 2.5 over 0.5 is 5. So you have 5 equals, write this, sure, 5 equals b 2 minus -1. That's b cubed. So b is the cube root of 5. So, right, because when you divide these equations, a's cancel out, and then you're dividing the common base, so you subtract the exponents, and then you get cubed. You take the cube root of both sides, and you get the cube root of 5. And then we need to figure out a. So we don't know a yet, but we now know that our function looks like this. And you can plug in a point again and solve for a. So say the first one, 0.5 equals a cube root of 5 negative first power. So a is 0.5 over the cube root. Oh, I'm sorry. I was right. 0.5 over the cube root of 5 to the negative first power, but that can come up into the numerator. And you have 0.5 cube root of 5. I don't know what this number is. I don't have a calculator on me, but this is your formula. So cube root of 5 over 2 times b, which is the cube root of 5 to the power of t. So that would be it in exact form. And the one below this is very similar, but you are given the initial value. So you're given this, so that's similar to the first one that we did. Part B at the top left, top right, is it's not exponential. You can look at why that's true. Part D is also not exponential. Again, you can verify why that is false, or you can look at it, you can see it pretty quickly. And, well, this is definitely not exponential. It's not monotonic. Here it's you're going up and then you're going down. So it can't be exponential. So that's this worksheet.